Most explanations simplify how airplanes fly, but the real story is much deeper. The real story is deeper. Most people believe wings work like simple ramps, pushing air down to lift the plane up. Others say air on top travels faster just to meet up at the back. Both are incomplete. The truth is a symphony of forces working together. It's not just Bernoulli, multiple forces work together. So how does a 400-ton aircraft stay in the sky for hours without falling? The answer lies in air, a fluid that transfers momentum. But here's where it gets even stranger. Air may feel empty, but it behaves like a flowing fluid. And when it moves around a wing, things get interesting. Now watch this carefully. Air isn't just gas, it's a medium of force. To understand flight, we must understand the fluid. To master flight, engineers calculate everything: air density, velocity, wing area, and the lift coefficient. This is the math of the sky. First, air density. The thicker the air, the more molecules there are to push against. More molecules mean more lift. Next, velocity. Notice it's squared. Doubling your speed doesn't just double your lift, it quadruples it. Speed is everything. Then there's surface area. The larger the wing, the more air it can deflect. That's why cargo planes have such massive spans. Finally, the lift coefficient, a number that represents how efficiently the wing's shape can manipulate the air. Now let's look at the first key force, Bernoulli's principle. When air moves faster, its pressure drops. The curved shape of the wing accelerates air over the top. This is Bernoulli in action. But it's only one part of the puzzle. The pressure difference creates an upward force, not suction, but a physical push from the higher pressure below. This pressure imbalance is a foundational reason why wings work. But let's go deeper. This is where most people get confused. The angle of the wing, the angle of attack, is just as vital. By tilting the wing up, you force even more air downward. As the wing deflects air, it generates massive amounts of lift. This brings us to a second, equally powerful law of physics, Newton's third law. If the wing pushes air down, the air must push the wing up. Every action has an equal and opposite reaction. Lift is actually the result of changing air momentum downward. It's a massive physical exchange of energy between plane and atmosphere. So, flight isn't just Bernoulli or just Newton, it's a combination of both working in perfect harmony. The air pressure pulls from the top and the momentum pushes from the bottom. Together, they conquer gravity. But watch this carefully. If the angle is too steep, the airflow separates from the wing, destroying the pressure balance. This is a stall. Without that smooth airflow, the 400-ton giant loses its grip and begins to fall. Physics has its limits. Think of it like this analogy. The wing is like a spoon-bending water flow. Air sticks to it and is forced downward. This is the Coanda effect. It helps air follow the wing's curve, improving lift efficiency and keeping the flow attached. Without this invisible bond, lift would be far less efficient. It's the ultimate team effort of fluid dynamics. Planes don't just float up, they need speed. As speed increases, airflow and momentum transfer increase until rotation. Lift becomes strong enough to overcome gravity. Gravity pulls, but physics pushes harder. The sky belongs to the fast. Quick challenge. What primarily creates lift on an airplane wing? Air pushing down or pressure difference? The answer is C, both principles. They are two ways of looking at the exact same physical reality. And here's a myth bust. Air molecules do not need to meet at the back at the same time. Physics is about forces, not timing. But lift has a cost. Wingtip vortices, spirals of chaotic air that try to drag the plane back. Engineering is a battle against drag. Winglets tame these spirits, turning wasted energy into efficiency. Every detail is a masterclass in aerodynamics. At 30,000 feet, the air is thinner. To stay aloft, the plane must move faster to capture enough molecules for lift. It's a fragile balance. Higher altitude requires higher speed to keep the momentum transfer strong enough. Airplanes don't fall because they are constantly creating lift every second through relentless motion. Motion is life. No speed, no lift, no lift. Gravity wins. Motion is the only way to conquer the void. So next time you look out of a window, remember, you're riding on invisible physics, perfectly balanced and engineered. You're not just flying, you're mastering the air itself. Welcome to the elite science of lift. But what if I told you some planes can fly upside down and still not fall? How does that work? We're breaking that down in our next investigation. Stay curious. Like and follow Learn with Adeesha.